40, 40 something? Teachers? Hello, teachers. So it's my pleasure actually today to present Chiara. Chiara is from St. Patrick, and if you check the booklet, you'd see that people from St. Patrick. So if you check carefully, they have presentation on learning skills, and they have presentation carousel by Fox on flipped classroom, actually mathematics and science, and Chiara will present on inquiry-based learning and collaborative inquiry as well. So we have worked with Chiara, and I've seen her work, and I don't want to get too much, and I'll talk after that. Being very impressed actually the way that she's worked with the department together, because we're all in this together, and how they make decisions collaboratively, and what to study and how to go about, and how this led to the inquiry-based learning and referred to well.
Thanks, Barbara. As mentioned, my name is Chiara Tan, and I'm from St. Patrick's. We don't really need to introduce ourselves in terms of names because I won't remember, but just a show of hands, how many people are math teachers or have been math teachers or have ever taught in a math classroom before?
Oh my gosh.
Perfect, because I don't know when it's student success.
You're the only one.
It's okay. We did sign, there you go. So you can follow with us. I won't go too deep into anything. Student Success Conference can be a bit challenging because there may be administrators, there may be people in other positions. So basically at the beginning we're going to go through what I've done in my classroom for my students to be able to explore, to inquire collaboratively with the content of math. And then I will also talk about, as Barbara said, our department has done collaborative inquiry as a department and as a board with other schools in our board. So there's ways that you could maybe then take this model, or the idea that if it's good for our students, it might be good for us too, and use it with other PD sessions in your schools as well. So there should be handouts sort of on the tables, so help yourself. As always, you need a definition to start. So this definition here says that inquiry requires more than simply answering questions or getting a right answer. And unfortunately, that's what a lot of people think about math. It's just about getting the right answer. So inquiry is supposed as investigation, exploration, search, quest, research, pursuit, and study. So all of those things can be involved in inquiry in some sense. And it's definitely enhanced by involvement. So we always talk about student engagement in our classroom. So if inquiry is a way to get them engaged, then we should try it, at least give it a try. Okay. So as math teachers, I think everyone who is a teacher at some point, or to some extent is a little bit of an idealist. So we think that our job is to do something. So we are transformers. What do we transform? We transform wonder into knowledge. So the idea that a student comes in, doesn't know necessarily, but they do come in with wonder, so we can do that with inquiry. We can transform intuitive understandings into knowledge creation. So students, especially in a high school classroom, have already been in the education system for 8 years. They don't come in with nothing. They have something. So the idea that whatever life experience they already have, we can then create the knowledge we need them to create. Also, in the same sense, natural curiosity. So if we can help them to hone their questioning skills, that's important. And then we transform ideas that they have, using the language that students have, into some sort of formal understanding. So we're the ones with the idea in mind. We have a learning goal in mind, we have success criteria in mind. We know where we're going, and we need to take their ideas and transform them into our ideas, or our goal at the end. So characteristics of inquiry-based learning. What must it look like, or what must it have? So authentic inquiry begins with questions and problems that students want to find out more about. And back to that whole idealistically, they come into our classroom going, yes, I want to know everything there is about math, but that's not always the situation. So how do we work with that? So we do know that they are naturally curious, that they can inquire, or that they have that curiosity. So what we do is the teacher initiates the inquiry process, right? We know what we want them to get at, and once we sort of make it accessible to them or make them want to know more about it, then they will want to know more about it. And I've seen it in my classrooms, and they end up asking more questions, which is important. The other nice thing about it is that it's collaborative inquiry, so the entire class is working on a common goal. Right? The common goal of understanding is that students get involved, learning new ideas with different perspectives, and then somehow contributing to a general knowledge base for the classroom. So then the teacher's job of facilitating at the end would be to take all that information and somehow summarize it with the language that we intended that they get out of it at the end. So these are the characteristics of what makes inquiry-based learning happen. Okay, and it also fits into many of the other terminology that we already have in teaching, so the big ideas. So the big idea of teaching and learning through inquiry-based learning is co-construction. So none of the definitions come straight out of the textbook. If we can possibly get them from our students, it'll be more meaningful from them. So co-construction, it's important to bring the class together, to check in, to share big ideas. It starts with the words they already have. The teacher then facilitates, and the teacher's role is critical because it's our job then to move them forward. If they have grade 7 language and grade 8 language and we have them in grade 9, what can we do with that math language they already know and bring it forward? And this is sort of the crux of being a teacher. We need to decide when to intervene, how often, how much, what to give them, and still contain or sustain that momentum. Because if they get stuck and we're not there, then they really struggle. And I have some examples of that afterwards. Students are involved. As I said, it's something that we want to do in terms of engaging students. So they're involved because they have to challenge themselves. Because if they're trying to figure something out, just like anything, we do that all the time, when we play a game, when we are trying to entertain ourselves. So I always say to students, how come you're willing to do a crossword, a Sudoku, or something in that 24 free newspaper? There's no prize at the end, there's no reward. We are willing to work towards something, just a matter of putting it in front of them so they have something to work towards. So they will challenge themselves, but also to the practice of revisiting initial math concepts and ideas by themselves, but also as a class. So they do it in small groups, they can do it in large groups. And I have models that I've used in my classroom where it's individual inquiry, where they look something up first, or they think about it first and then share. And I've also done some lessons as a whole class because sometimes we run out of time, and if we do too many things individually, then we can't move forward as quickly as we want to. And the last part that is very important is that they have to reflect. So they reflect on the ways in which current understandings differ from their previous knowledge. And I've made direct connections to grade 7 and 8 terminology before, especially in grade 9 applied, because they have heard of most of the content before, just with different language. And in terms of the presentation upstairs, earlier this morning, the keynote, we need to establish a culture where ideas are respectfully challenged, tested, redefined, and viewed as improvable. So the idea that math is a science, so math is a language, math is a science, and we're trying to train students to work in that direction, but also that no matter where they come in with, their idea can be used towards the common goal for the classroom. Okay, so then we get to this part. How come we're not all doing this all the time, every day? Because it's not that easy. It doesn't always work out, and there are some challenges and concerns that teachers have shared before, so let's try to address some of them. The first one is, how to teach with an inquiry approach when there are so many curriculum expectations to address? And I guess this general response works for many techniques, but it works here as well. If we focus on the big idea, then we don't have to do one inquiry lesson for every single specific expectation. You can do something that maybe introduces the entire unit at once. It brings about all the language you need, and then you can refer back to that. And I also like activities like this because if they're big enough or important enough in the student's memory, you can then refer back to it and be like, remember the day we took those blocks and we did this? Remember the day when we went to the computer lab and we looked at this? And even just the fact that you did something slightly different makes it something you can refer back to as a big idea. Another misconception that comes up sometimes is that inquiry-based pedagogy means letting go of the class and letting them discover everything on their own. But in reality, as I said, the crux of being a teacher is to use our judgment and decide when to intervene, when to help build new knowledge, when to make connections, or when to help them make connections. So it's not, if you've heard or you feel, because there's a little bit of that fear, if I let go, and why don't I just tell them? Because it'd be so much easier if I just told them the answer, everything would be great. But we need to be able to let go of that a little bit. And lastly, that inquiry-based learning stands in the way of other forms of effective teaching and learning. But in fact, I would say, and I know that with some of the flipped classroom stuff that Nick has mentioned before at our school, the idea is that you can do a lot more on-the-spot teaching. So we talk about teachable moments. We say that if this student is ready now, I better teach him or her that right now because this is when they need it and this is when they're going to use it. And that's when the best teaching really happens, if it's on the spot. So it's not standing in the way. It can support many different teaching and learning strategies. Okay. In the slide package, these 4 slides, there's 4 of them grouped together. They each name some structures I've used in my class, and I wanted to give, and luckily there are a lot of math teachers here, I wanted to give you some structures I've used before so that you can envision using it in your own classroom. So there are 4 of them. Some of them are more whole class, and this is what I'm going to describe, and others are individual, or you could do it in a partner situation, or maybe working with a computer or an iPad in smaller groups. So one type of lesson that I came across in Teachers College was a concept attainment lesson. So have you heard that term before, concept attainment? Okay, it seems to work well. We're going to try it, so you're definitely going to tell me if you think it works well. But the idea is that there is a search for listing attributes of something that is, so an example, and then something that is not, a non-example. And by doing that, then you can really define a new term, new vocabulary. So it works well because math is also about recognizing patterns and sorting, and those are skills kids do have, regardless of the content and how hard or how difficult they find that content. So the roles are underlined there so that you can see. A teacher will prepare some examples and non-examples. The students will identify characteristics of each group. The teacher then presents a new item, and the students have to attempt to sort that new item and say, well, is it more like this one, is it more like that? And the lesson I'm going to show you is actually on the next page. It says concept attainment example. And I use this example for grade 9 applied or academic when I'm teaching a certain I can do it from here. So we'll work on it from here. So this is a grade 9 concept, but I'm sure anyone, regardless of whether or not you taught math or not, can see the pattern. So here we go. The babysitter charges $9 an hour, and the DJ charges $25 per hour plus $300. And then I would continue to sort a few, and I'm saying I'm going to put this one on this side, and I'm going to put this one on this side. And your discussion, whatever you're comfortable with, we can already start and say, do you notice anything those two have in common? Do you notice anything that those two have in common? You could put it out there and ask, as I will. Banquet hall has $500 rental fee and $35 per guest as well. Should I put that on the left or should I put that on the right? On the right. Good. No fear, right? Perfect. How about this one? The car is traveling at a speed of 60 kilometers per hour. Left or right? Left. So we don't have to introduce yet any terminology. We just know that it goes with those ones. It's like those ones. For whatever reason, we'll get there. Sometimes I will do the same thing. Renting a Mustang costs $250 plus $50 per day, and the student will say, oh, miss, I know that goes on the right. And then I will say, okay, why did you put it on the right? And we start to get to the characteristics. So most students begin, I've done this lesson many times, grade 9 academic or applied, they say, well, there's two numbers and those have one number. That's a good start, because if there's two numbers, why can't I just add them together and just make one number? Well, they're two different kinds of numbers. One of them is a rate of change, and they may have already been introduced to that, and if they haven't, you could introduce it that day. Okay, so the first value that says $25 per hour, that's a rate of change. So I can use that. Plus, or they all say it has a plus. That also comes up a lot. They all have a plus in them. And then you can throw them off by putting a minus, which is good too. But the idea is there's something that doesn't change. The $300 you have to pay regardless of whether or not the DJ stays for 1 hour, 2 hours, 3 hours, 4 hours. So you really get the characteristics that way. And then at the bottom there, you'll see that I have a Freyer model template. So we can take the textbook definition, sometimes we look it up, or I find a maybe more student-friendly definition, we write it in, but more importantly, we make a list of characteristics. So if I wrote direct variation, which was the column on the left, the box there in the center, then we can make a class list of characteristics. They can make it in small groups, you can make it with a partner. Every time I use this model, it's still good because I think the kids still know the show. I think of the show Love It or List It, and I say, well, this is the must-have list. You must have this, you must have that, and you must have that. So if you have all those things, you become an example of direct variation. And if you don't have them, then you go in the non-example category. So this would be one way to introduce inquiry, but as a whole class. That's one structure I've used in my class before. I've done it for function, not a function, with grade 11s. Even for like terms and unlike terms, so new vocabulary. What else? I've seen an example in a textbook where they did it for polynomial equation versus some other type of equation. So you can put those all in. See what happens when I go back to Barbara. Is it going to change?
It's going to be okay. But it's going to go from the way now. Okay.
Okay, that's good. Yeah. All right, so then, I should have said first. The other methods don't have a formal name, but they're structures I've used in my class, and I'm just kind of throwing out a name that kind of relates to other math you've done before. So students are really good at the guess and check method in general. They try a number, see if it works, try another number, see if it works. They'll do that for a long time. So that's what I named this structure for my classroom. The idea that we're going to make a change to something, we're going to observe the effects. So then we're going to try something else. We're going to guess, we're going to check if it works. We're going to guess, we're going to check if it works. And I've done this as a whole class. And obviously this one can also be done individually. So I have 2 examples for that one. But it's very helpful. This is one of the times where I really like if you have some sort of digital simulation. So it could be an app that you're presenting. It could be a graphic calculator that you could show different equations, different functions. I'm going to use an online, something I found. The online one that I'm going to use is Explore Learning, which is, I'm not going to say older technology, but I feel like it hasn't been brought up very recently, and there are so many others. So it's just one that I happen to have a lesson ready for, so it's easy for me to make that, to share that with you. And students make the predictions, and they justify their choices. So once again in here, I wanted to try to include as many examples so you could work with them later in the class. So, and right touch. Display options. Distance time drive, yes. Okay, so in this activity, and I've actually used it with grade 7 and 8 students who come to visit our school and we have math workshops. This is something I've done before because the concept is pretty simple. But basically what we do is they have like a checklist of questions and I make all the changes. So this is still something you could do. It's sort of minimally intrusive. So if you're trying to move from someone who's always been in front of the classroom and that's their style of teaching, then you can insert a few of these without really changing what a person's comfort level is. Because the teachers need to make small steps as well. We can't suddenly become like, okay, now I'm going to do everything inquiry-based learning all the time. So this structure here, I have a list of different graphs. So I sit here and I'm like, okay, so question number 1, predict what the runner is going to do. So if you see there's a little character at the bottom, there's a graph. We normally name and say, oh, these are the time measurements, 1, 2, 3, 4 seconds. These are the distances from the starting line. Predict what do you think the runner's going to do. And they have a little box, and they will say either they are going to run and stay there, or they're going to run and they're going to go back to the start. So anyway, what do you think is going to happen? If I press go and this person follows that red line graph, are they going to end up back at the starting point, or are they going to end up at the, or are they going to stay where they are, 40 meters away from the start? Stay. There we go. So we get a few different opinions. We look at that run. A few kids cheer if they got the right answer, and we try again. So then I make a change, and I say, well, let's reset that. I'm going to do this. So I have a list here in front of me. Predict what just changed. Did I change the starting position, the end position, or both? We're going to predict. We run it. Okay, so now he ended at 20 meters instead of 40. And then the next question, which I'm sure math teachers are already thinking, is when did he run faster, right? So it's all very progressive, but you're working baby steps with what they already know. And it's not too difficult of a lesson to have or to encourage discussion, because you can easily ask a student to justify why they chose what they did, or you can ask someone, you can maybe take a vote. On some of them, you kind of get a split in the class, so certain students will be like, no, I think it's this one, and then you can ask them to convince each other. So to say, no, this is what's going to happen, and then we play it and see. So when did they run faster? Well, he ran faster the first time. You can bring out a lot of math language about rate of change again. You can talk about the units of the question, the steepness of the line. Because the way this gizmo works, you can add more points. Then I change it so that we do let the runner go. There we go. We make the runner, run and go back. And by the end of the gizmo, we have 2 runners. They're racing each other. We have them running back and forth as many times as possible. So they're engaged because it's interactive. And it is free software, just a matter of getting that username that I think the board still has somewhere. I just don't know what it is. But yeah, if you ask Kathy, you can find out, or ask Barbara. Yeah. So this is just something, they have many, many gizmos, and they are set up for teachers. There is lesson info available. Sometimes teachers upload lessons so you can actually use what they already have. So there's a student exploration sheet if you were doing it in a computer lab, or with iPads they could do it themselves. And there's some way when you're sorting, you can actually search by Ontario curriculum as well. So it was something that the board invested money in quite a few years ago, so there haven't been recent workshops on it, but I have a lot of lessons that I had made or created at that time. So I still use it from time to time. All right. And before I start screening again, another lesson sample. So if you take a look, the next one says, guess and check what partner or individual. So in every textbook, it doesn't matter which company you've chosen, there's normally some lesson that asks students to explore when they're introducing a new concept. So this is a lesson that asks about transformations of parent functions. And in this package, I have a lesson that was also an investigation of parent functions, and transformations of parent functions, that my grade 10 students completed recently, just last week. And the idea is that they're going to find the purpose or the role of the A value, the H value, and the K value in a vertex form of a problem. This lesson almost does the same thing. This is a grade 11 one. But if you take a look at the format of it, it's about A to K. There is no white space, it's all text. And students tend not to be very good at filling in information when you ask them to follow it from the textbook. I don't know why. It's the exact same information. But I found that. That's in my experience, and maybe you've experienced the same thing. So as soon as I do something like this, and this I just made it smaller for you, but it was a single page for each one, they now have somewhere to draw what they see, to record and answer those reflect style questions right here in the spot. I have another example where I literally drew boxes every time it said explain, because they wouldn't otherwise explain. You'd have to give them the structure for it. So it's not necessarily that you have to invent a new lesson completely. I can take one of these lessons, or take one of the lessons from Gizmos. I think that's where this one comes from. and just make it more student-friendly. Because we do want them to explore on their own. These explorations, investigations are really good. Because I was searching one of the textbooks, you can search the online textbook by word, so I literally searched the word explore, and they don't use it all the time either. They use it when they're introducing a new concept. So these types of lessons are good to introduce something new when you want students to be able to play, manipulate, make their own conclusions. So this is another thing you can do. You can take a lesson that's in the textbook and modify it. So this one here, we went to a computer lab. We worked with the GSP, I think. We had our parabolas, we moved the sliders. There's other software that does it. Desmos, Monica here was telling me about Desmos. Desmos has sliders. TI Inspire has a program you can download from TI Connect that would have sliders. So the idea is that the lesson is that you want them to explore these three things: what tools you use, whether it's individual, like one computer, 1-to-1 ratio, or one iPad between two students. That really wouldn't make that much of a difference. The important thing at the end is that they figure it out for themselves instead of me standing up there and telling them. Because I could easily do that, right? This is where that time piece kind of comes in. When we're crammed, teachers get a little nervous, and they're like, well, I could just tell them what A does, and H does, and K does, and the lesson would be over, and they can go practice. But I'll show you later that, as I said, my grade 10s just did it. They did have something to say about it, so it's kind of interesting to hear their opinion. Stefano was in my class for this one. Stefano, do you remember that they had to deal with this problem? The backyard paving company charges this much, and learn all on their own about inverse functions.
Yeah,
okay.
And I thought it was interesting how they, at the end, they realized that xy is yx on they deducting. So I thought it was quite amazing for grade 10.
So, and once again, this is the activity I did, and you see this was, because it was a bonus activity, it was an enriched class, and we're working on some grade 11 concepts. I have a marking scheme here, but the idea was I took this question, I took snapshots of things I wanted to keep, like the table. I was using it in my classroom, but I just left them the writing space, because otherwise they wouldn't write, and I wanted them to think about it. So it can be just that simple, right? Use something you already have. No manipulatives needed. I think I found mirrors, because it asked you to find a line of reflection, so over a mirror, and we had those in our school, but some of them visually saw it anyways if we drew it in. But in the textbook, it would have looked like this. So write the equation, but they didn't leave any space, right? So that students just don't know very well, especially in grade 10, and I'm sure more so in grade 9 applied, how to do all of that. And then reflecting goes all the way to O. So already that's intimidating. We're going to get close to the end of the alphabet, and have we learned anything yet? Hopefully, but all of those things can intimidate students. So I've left examples in here for you to just kind of take with you and think, okay, well, is there a lesson I can imagine doing the same thing with? So that's what this lesson was. It was, how are the slopes related? How are the y-intercepts related? How are the equations related? And the situation itself was about area and cost of paving. So this is one of the places where I would say I have a weakness. Unfortunately, I'm not really good at coming up with the really good, rich problems where students are like, oh yeah, I make connections to that every day in life. They can imagine this. This is a textbook example. They probably can't. I don't think they've ever necessarily purchased stones for interlocking their, I don't know, patio, driveway. Like, we always use those examples. So if anyone here has better examples than these, I need your help with that, because generally speaking, I'm a person who enjoys math, maybe just for the sake of enjoying math, and when I'm trying to relate to grade 9 students who are looking for that real-world connection, these problems could be even better. So it just takes like a group of people to sit around, and then suddenly the problem becomes better and better and better. So I did mention I was going to show you what my students had to say, so I want to show that now. So I asked the students, because recently we've been doing a lot more of these explore kind of activities, and I just said, what do you think? Like, I haven't been telling you anything, I've been asking you to figure it out on your own. And this is what one student said. They said they find it a challenge, it's their own learning, it's different from my other classes, which was interesting to hear. It's unique, and I get to work with other students. So that's what this student liked about it, but they also said it was confusing. So sometimes you do need to be there to intervene. Not sometimes, a lot of the time. Because more than one student you'll recognize, I just picked out a few trying to get different opinions, more than one student said that. They said, you know, if I get stuck, it's not fun. I don't like it anymore. So our job is to make them only be stuck for like, 10 seconds, no more than that. This one's hard to read, I'll read it out. Once I found the answer, it sticks in our mind better than if you just told us. Teaches students investigation skills. Dislike, if the answer is not found, it could further confuse someone. So back to this idea that if they get it, it's great. But if they don't get it, you need a backup plan. You need to be prepared for that as a teacher. I like finding it for myself. Sometimes it takes up too much time. So even the student is worried about time. I thought that was quite impressive. So it's not just us that's worried. I like that it was hands-on, it was group work, it was group discussions. It was hard, 101. It was sometimes confusing.
Chiara, I just want to make one comment. You know, I don't think it's a problem that kids say it's confusing.
No.
Something new is confusing. The whole idea is that they actually work it through is what we want them to do. I mean, we're just talking about this. All of us took math in university. And all of us would take copious notes and go home and say, what the hell was he talking about? Because he talked so fast, he'd been moving those boards, and he had to figure it out. That's how we learn. We didn't learn by the teacher telling us. We learned by figuring it out, by analyzing what we heard.
This student was funny because he wrote down
Sarah,
this.
can I add a second one to that?
Yeah, no problem.
I think as a classroom teacher, if I don't have students telling me that they're confused or don't know, then to me, I don't have a successful lesson because to me, there's no feedback. It's almost like that dog in the back of a car window, that when it hits a bump, it goes up and down, yeah, I get it. But really, do they know what's, no, but that's, you get a lot of that in a classroom.
Or,
But
or as a teacher, you're not offering anything new to learn.
Yeah,
So
but the
there is
thing-
no confusion. So because the learning comes through confusion.
And Mark, that's good of you because that's your measure of success in the classroom. And I'm sure someone else, unfortunately, will measure it by a test score, homework completion, something else, right? So we need to rethink ourselves. What could we do to make our lesson better? Because that will make us better teachers. And for me, I agree. If they struggle, that's a good thing because then they're actually learning.
But I think it also goes back to the comment that, especially if you've got the students coming in 9 applied, they don't want to fail, that's why they don't get the answer. Yet, being a former computer science teacher, I always told my students, the more mistakes you make, the more you're going to learn. They got that in computer science, but trying to encourage my students to do that in math is so foreign to them coming into my classroom.
They want the right answer. That's something I was saying that people who either don't know a lot about math or even just a general view of math is that you have to get the right answer. That's how you do it. But there's so much learning that happens when you get the wrong answer that we should spend more time on the wrong answer than on the right answer.
Sometimes the idea is some people just want an answer, and it doesn't make sense, they have no clue, it doesn't make
Yes.
sense. But they're saying it's 400 feet, but you're asking for time.
Yeah, it's true. Yeah, they'll tell you
And
400.
they're just happy they got an answer, so confusing is good.
Yeah. Confusing is great. This student was brutally honest. If you just told us, I'd space out and I would get left behind.
Chiara, this isn't your calculus class.
This is my grade 10 enriched class.
This you rich.
They do. Now, the only defense, I don't want to defend my students. The only defense they have is that I gave them like 5 minutes before they left for lunch. So I was standing between them and lunch. So they just scribbled it over.
They're studying these concepts that are a little bit above their level,
Yes,
so
yeah.
like the inverse function, for example, and
Yeah.
she said to them now use inverse operations on function f to solve for x. So they didn't want to solve for x in that function f. It was totally, so they wanted to pick a point actually to do that. So they didn't want x on the left side. So that's why it was confusing. I forgot that. But in the end,
And the one last student who wrote this one down, she would be the one person, and you're going to have that in your class. Not one technique is good for every student. So she is, a high-achieving student, received all the awards in grade 9. We know who she is, and she said, I prefer you just told us.
Yeah. You're wasting my time.
She said, you're wasting my time. And the other students, by the way, a lot of them are gifted, like gifted IPs and all of that, but they just need to do something. So if I told them, they'd be the ones who were bored. So she's the type of learner, and she's very aware of the type of learner that she is, that would rather be told and then get to practice. So her learning and inquiry is when I get to practice the problems. Whereas the other students were okay with learning through inquiry. She wants to practice and inquire and learn to go. So you definitely need to mix it up. You can't just do one with a word back. So those are all my structures, inverse structures. So after all of that, as I said at the beginning, I should have said front side. Basically, what could teachers do to learn in this way? And that's sort of the next part of the presentation. So if you look at the very last page, working with the math department, they often get those little feedback forms from teachers. You know how we fill them in? And this is their summary of what teachers want. Actually, sorry, let me go back. That was here. What teachers want. So teachers want to focus on problem-solving lessons. They want to learn more about co-teaching, about learning goal success criteria and descriptive feedback, about common assessment, about grade 9 analysis, about the flipped classroom, about technology. And how do we get to learn about all those things? Well, if we were the working groups, we're collaboratively inquiring, so it works to get the same thing. When we got together as a group, we had goals in mind. I'm missing a slide. Got deleted. It's on here. It also said that teachers want to be involved in PD that's local and good for them. It's on the sheet, but it's not over there, so keep that in mind. We did these collaborative learning sessions in schools. So there were some at Morrow Park, there were some at St. Pat's, there were some at St. Joe's Wellesley that I was involved in. So we were doing PD within our schools. And I know that you've teamed up with Lieberman, so BMT and Lieberman and other schools are getting together to do PD that's meaningful for them. So when we did, I'm going to give you a structure again that you could use. When we did the collaborative inquiry with the math teachers for a lesson study, we got together and our goal was to design and implement a 3-part lesson that involved problem solving of some sort, to develop strategies to improve students' mathematical communication, and to understand student mathematical thinking and use it for teaching and learning. So the assessment for learning piece. So those were our goals for the day. We got together and then this is what our day looked like. So because it was a lesson study, we had to talk or spend the morning at least speaking about the lesson itself. So the lesson, this is one that happened last May, I remember, was created with myself and another teacher at my school, at St. Pat's, and then when we shared it with everyone, then we could get feedback from other schools as well. So it all depends how much time you have and who you have the opportunity to work with. You could have planned the lesson collaboratively as well. We did it with 2 teachers. And then the lesson study involved going over the overview of the lesson, the learning trajectory, which is really important if you're thinking that the students are coming from a grade where they've already been exposed to some piece of this, some element of it. So you want to be able to look back that way. We discussed the learning goal and the success criteria and descriptive feedback opportunities. And we looked at the lesson in the 3 parts. So I will kind of break that down, and then afterwards we visited the class and debriefed later. So the first part was, as I said, to look at the roles that the teachers would have in the classroom. So when we actually went to the classroom, this is the structure that we used. There was one person teaching, and the person teaching knew the students well. That's the lead voice. We had co-teachers that would help by being at the board and jotting things down, taking notes so that the lead teacher could lead discussion and not have to be doing both. It also helped because then it spread people around the room. Imagine how intimidating it is to have like an extra 8 teachers in your classroom if you're in grade 9. So definitely works when you're spread out. We had knowledge mobilizers, and in this role, your job would be to to be the person who, if you notice something happening at one table group, you would let the lead teacher know so that there's still only one voice in the classroom. Because it's really confusing for students when someone who's not their normal teacher is teaching in their room and telling them what to do or asking them this. So if the lead teacher, the lead voice is the only person speaking, everyone else's job is just to mobilize information. So 2 people at least would do that. And then we had other teachers that were inside the groups or outside of the groups, and they were not speaking with the students, they were simply observing. Because sometimes you want those natural conversations and interactions to happen, and if we intervene, then they don't happen. So students will say, no, you weren't supposed to do that because of this. If they kind of look at you for the answer, and you're like, no, sorry, and it feels it's really hard not to say anything, then at least you've let them struggle a little bit more on their own, and you can bring it to the attention of the knowledge mobilizers and the lead voice as well. So this is a structure that we used several times over the last few years, and in doing that we had great discussions about learning trajectories. So the grade 10 lesson that we prepared for that session, the one I'm going to show you an example of, it was about linear systems and solving systems of linear equations. In grade 7, in grade 8, and in grade 9, they have some understanding of equations, of the relationship in a linear equation so that there's a rate of change, how to find solutions, so you can do it graphically, you can do it through a table. All of those structures were first introduced in grade 7 and 8. So we wanted to have a really good discussion, and this is where, like I said, teachers do a lot of learning when they learn from each other through this way. Then we also, as a teacher group, wrote down what we thought the students might say. So that's something that, whenever you have the opportunity to do that, is a great way to anticipate any lesson, whether it is collaboratively or not. But if you can do it collaboratively, we came up with 6 incorrect answers and 6 misconceptions, and we addressed how we could take any of those misconceptions and bring them back to the students and change it into what we wanted them to know. So if they came up with an incorrect equation, then it might just be about reading the problem. Let's read it again as a class. Let's take out this information first. Let's just list the important information. Combining like terms incorrectly. As soon as you bring it to their attention that those are not like terms, you just get one student to say, is 4.5x and 475x like terms? And they'll say no. And then someone else will be like, oh wait, then you can't add. So you can pick up those pieces of information because this was sort of a summary lesson, they would have been familiar with it. So by discussing this with other teachers, you come up with more incorrect solutions and very creative ways to address them in the classroom. So it's not just one person's way of doing it. In the classroom as well, then we had, as a board writer, so we wrote down things after the first activity. So in the first activity, they were just kind of brainstorming. We got graphing is a method for solving, substitution is a method for solving, elimination is a method for solving. Describe how they work, and we wrote that down.
I believe they had stations that day, the recorder, like they had 3 stations, and the teacher asked them, here's the equation, if you think that it's better to solve by graphing, then you go to that
Right.
corner. So it was a corner activity.
It was a 4-corner, you're right, yes. So that
So
was,
now I remember
we were trying
it's coming back
to,
to
Barbara
that.
was there.
Yeah, I was there.
We were trying to get them to mention those 3. So by having that activity, which is
Yeah.
a 4-corner activity, they chose why one method might be better than another in a certain situation. And in doing so, they talked about all 3 methods, so that worked out. During the lesson themselves, we had a problem, and the students solved it by substitution. Most of them used substitution, and I think the teacher at the time said, oh, I think we just taught that, that's why, it's just stuck in their head. A few of them used elimination. So I just wanted to show you that part of this and the sharing of it afterwards is that you do want to collect all that information and have some artifacts, and then even a teacher who wasn't there, who couldn't participate, you could use that as other PD. We could have a whole discussion about students' work, students you don't even know, and we could still have this really rich discussion. So keeping artifacts, the math department is excellent. I have so many different resources from different places, from different schools, so that's wonderful. And then afterwards, we decided as the lesson we're going to have some homework practice problems, and they started that before they left. What we did lastly is that after period 3, we got back together and we had a discussion. Because I can tell you already, the handouts that I gave you, there's things about them I want to change. That's what happens. As soon as the lesson has finished, now you want to change something. I remember the lesson I was saying about the inverse functions. The one thing that stumped the students that was very frustrating, and remember when students get frustrated, is the grid I gave them. I randomly cut and pasted some grid paper. They didn't like it. It doesn't fit the numbers well, so they couldn't fit them in, and then they're like, Miss, if there was like 2 more columns, it would have been perfect. So, I don't know, I just cut and paste, that's what we do sometimes. So, this discussion afterwards is very important, because any lesson, when you put together 8, 9, 10 teachers in a room and say, okay, do you think we could have changed something? Well, there you go. So the 4 part, the activity with the 4 corners, no one went to the not sure, so that's something we observed. Some didn't speak up, they were very shy, so was there a way that we could have made engagement a little bit higher? It was a quick activity, which was good. It helped them to make choices. And we noticed some positive things. They didn't just follow the crowd, they made up their own mind. So sometimes when you do activities like that, they will just follow the crowd. So that's something we commented on. During the lesson, they were confused by different things. If they didn't know what a break-even point was, they would have been confused about that. But luckily, that was yesterday's lesson, so that was good, right? Like, so those things come up in discussion because as an observer, especially if you're doing it with someone from another school, you don't know what happened. So, the day before, you don't know who the strong student is, who the weak student is. So you can be impartial. You can sit there and just make comments on rich discussion that's happening at a student's table, whether or not the lesson is inquiry-based or not. This was a problem-solving structured lesson. They could still, you can make notes about it and be impartial and get their opinion. If they were confused, we made a list of things. So this idea, I guess if I could try to to take both ideas and put them together, what I think you could do is if you had a team of teachers work together and make up a lesson that was based on an inquiry activity that you find somewhere, and then try it in the classroom and see how it goes, then you get the feedback you want to see whether or not this is worthwhile. Would you try this in your classroom? I mean, I've given you feedback based on my students' opinions, but does it work in your room? But you could try it. You could try it with a number of teachers in your department. You could have a day like this where then you talk about the lesson, what went well, what didn't go well. You can tweak it for next time. So it would be important if we kind of ensure that students get a bit of this and that teachers get a bit of this as well, both parts. So yes, any questions or ideas that you might want to share, things that have happened in your schools that are either similar or comments? Great, go for it.
What I have noticed in my teaching is what works in, say, first semester grouping I have. I come to the next grouping and it's a total bomb. And it's the personalities and the mix of students you have. And the one thing, thankfully, for the years I've been an educator, I'm picking up to realize, okay, this is not going, what else can I come up with? And to me, it's so important to get to know my class as quickly as possible, because I think of the way I was taught and colleagues I've seen over the years where they would go to their binder, okay, we're here, we're doing this, I'll pull out my master, photocopy it, and bring it in. It doesn't work with the kids. They have different mentalities, and the thing is, we want our students to learn from mistakes, but we as educators have to be able to accept the mistakes. It didn't work, it's bomb.
Right,
I'll
and
go
learn
somewhere
from it.
else.
That's exactly the same model. Like, you need to inquire, you need to try it, you need to learn and see if it works, and you need to revise it if it doesn't. Now, I agree that it doesn't always work for every group of students, so that's why I wanted to introduce 4 different structures, because sometimes that distance time one, because it's Gizmo and you can have online access for each student, I could do the same thing where everyone's sitting at their own computer, and they might discover, the same thing, and then we have a discussion later. If I know that those students are going to, I'm trying to think of some situations, sometimes students maybe aren't as respectful of one another, so if one person puts their hand up and they're like, no, I think the person running is going to do this, and the other person's like, why do you always say that? It's such a dumb answer. Like, you need to address those things in your classroom, but also you may not want to make too many opportunities for that to even happen. Just kind of stop it before it does, yeah, right? Because then you're opening it up and that becomes the focus of the class. So know about your student, try to get to know your students as much as possible and see if they're good candidates for which type of these lessons. Sorry, Kathy.
Yeah, I just want to say that some people might criticize this work and say, oh, you're using these kids as guinea pigs, or you're testing or trying these things out, and you don't know if they're going to work. The whole idea of teaching, you never know if what you're going to do actually works. And sometimes we wait way too long, wait to the test. I think that's too late. When it comes to the test, you can't really change much because you're ready for the next unit. I see what you and your math department and the math class are doing are you're constantly putting a lens of analysis on what you do. And your yardstick, your measure stick is the kids, first of all, their effective response, but also their achievement during the class. And then you adjust. To me, that's not messing around with kids. That's trying to improve your teaching as you're teaching and not waiting for the test. So this inquiry thing isn't a free fall. It's very systematic. And what I also hear from you in St. Pat's group is that you all care about doing this work, about improving your teaching every day you teach, not just, oh, this one semester, but every day. You know, I was at Nick's and I'm hearing about his work and the things he's very systematic about and that he's noticing. And I think that's all we're asking from the math department is that we all become more systematic in what we do and not just try to follow a textbook, but think carefully about it. So I really appreciate it. And I've got to say, I'm really appreciative of how explicitly you're articulating this process that we've been working for now in our secondary group now. We've been doing it for 3 years now.
Yeah,
So-
and that's why I participated in a few, and then
Yeah.
I think the best thing is too that we had the opportunity to lead a few.
Yes.
So that's when you really learn something, right? You take ownership of it, you have to do it, it's gotta come out. So I know, I do understand, I appreciate the process because it gives us the opportunity to talk.
One more question?
Yes.
Okay.
Oh,
Two more questions.
Does everyone have access to Gizmo?
Yes.
You do, and you said you have a password?
Yeah.
Do you have it on
They're
your
both,
computer?
well, I don't know.
It's also,
I know
it's
it
also
is,
back,
It's on
Password.
license.
21st century. Yeah.
Yeah.
Yeah,
So
because
on
I know
the-
I've changed mine so many times, so mine isn't anymore, and there's probably a generic structure for
You
like.
know what, if you
comes
go to
first.
intranet and then you go to 21st C and then there is a drop down, there is password, where you can get all the passwords there. One more question? We have one more question.
Feel free to email me if you want any of these lessons like as soft copies, because right now I was going to, I think SharePoint, the slideshow and the PDF files are going to be shared, but if you want anything that you can modify for your class, just email me and I'll send it to you. Great.
Okay, on behalf of all of us, I have to thank Chiara. Actually, as Kathy mentioned, we've been working with State Country for 3 years now. And we not only for today presented, but really from as a master faculty, you really have to thank the country that actually they have opened their doors. We're there and blessing our Teresa as a country and Monica as well all the time. And most of the time we go in uninvited, and then Chiara opens the door and said, "Oh, okay." So
That's how Stefan ended up in my class.
yeah,
So
and not only that, but this lesson that she was showing over there, there were probably 30-something teachers, and probably Monica, you saw your writing over there because you were there too. There were 6 or 7 schools that day participating on that inquiry-based learning, and the whole idea is making students think invisible. And having the attitude, not what students don't know, but having the attitude, let's build from what they already know. And Chiara made it very clear, time and time again, that they come with some knowledge. Let's build from that knowledge. Really, I'm happy. Thank you so much. I think we have to go upstairs for the end keynote speaker. So if you want to get the